Hello everyone. Today we are going to start a new chapter. This chapter is for the enrichment. It's called Chemical Equations and Calculations. From the name, we can predict that we will be having some equations and we want to calculate something out of that equation or a reaction. So we will be going through some aspects of this chapter and explain them in details. So let's get started. First of all, what is a chemical calculation? So let's say that you are trying to make a drug, okay, legal drug or a medication or any chemical compound or a substance. So after that, you are going to calculate or find out the percent yield. So if you don't know how to calculate or how to do some chemical calculations, you wouldn't be able to even predict how much you produced. Through this chapter, we will be able to go or explore some stuff that you will not get from maybe next year or stuff like that. So this is the basis of it, and you have to read everything in details, and you gotta pay attention to every single word. Now I'm going to explain them and tell you which thing that you need to memorize and which thing is important, and let's get to it. First of all, so if we have a chemical equation, from the chemical equations we have some stuff that we need to know, like which thing or which of these four or five things is gonna be in our equation, or they might be all of them in one equation. So let's get to each one and see what each one represents. First of all, the arrow. So it represents the direction of the reaction. So it's from the left to the right. Sometimes we have two opposite arrows, which means that the reaction is reversible. So we can from the product we can get the reactants. S right here, the letter S means that it's a solid. So the state of the substance is a solid. The second one is L. L means that it's a liquid. And for the G, it's a gas. AQ is an aqueous solution, okay? And you can see here the triangle above the arrow. It means that there is a heat and the reaction is heated up, okay? Or we can write it as heat, like the word heat. For this one, PT means that it's platinum. It's like a catalyst. Sometimes we refer to a catalyst by one or two letters of the name of that catalyst. So it's a platinum, okay? It's a catalyst. So a catalyst is like a substance or a metal or whatever it is. So we add it to our reaction to for many reasons, but the main ones are to accelerate the reaction. One of the conditions of selecting a catalyst that it must not be consumed through the reaction. Okay, so let's consider this reaction. So the formation of ammonia, it's like a Haber process. So if we want to form a NH3, so we will be reacting nitrogen gas with hydrogen gas to get NH3, the ammonia. Now let's see which stuff that we can get out of this reaction. So for the first one, so we can know that we have reacted or mixed up 1 mole, because there is no number right here, 1 mole of nitrogen gas with 3 moles of hydrogen gas, okay, to give us 2 moles of ammonia. This is the first one, the number of moles. The second one is that the state of each component. So for the nitrogen is a gas, for the hydrogen is a gas as well, and for the ammonia is a gas. Okay, this is the second one. The third one is the direction of the reaction. So the direction of the reaction is toward, okay, to the product. So this is like the three things that we got out of this reaction. So now let's move to the some points that we need to not memorize but to understand before we go further, okay? So this stuff that we got from the previous reaction, the properties of the reactants and the products, we said like it's gas and gas and gas. The relative numbers of moles, 2 moles, 3 moles, and 1 mole for the nitrogen. Number of moles, we've known that previously. The ratio between masses of substance. So let's say that we have already mixed 28 grams of nitrogen, okay, with 6 grams of 3 moles of hydrogens, and we got 34 grams of ammonia gas. The ratios between the volume of gases if measured under the same condition, so we just like convert the grams into volume, okay? So we have like number of moles, it's the equals mass over the volume, and you can like multiply the two sides to get like the number of moles. So we will get to it like maybe this lecture or in the upcoming lecture. Now let's get into each one individually. The first one is determining the properties of reactants and the products. So we have already mentioned that the G letter means that it's a gas state. So we are dealing or treating, or we are like in touch with some gases. So we are using gases in order to make a gas. Okay, so hydrogen gas plus nitrogen gas. The second one, determining the relative numbers of moles. So now, from this one, from the ratio between the numbers of moles of nitrogen and hydrogen, so we have 1 mole of nitrogen and 3 moles of hydrogen. So 1 to 3, the ratio. 1 to 3, okay? This is the between the nitrogen and hydrogen. So between the nitrogen and ammonia, so if you go to the previous slides, you see like we have made 2 moles of ammonia and we reacted 1 mole of nitrogen. So it's like 1 to 2, which means that 1 to half. So a half of like of nitrogen, we got 1 mole of ammonia. Okay. For the third one, the hydrogen and ammonia. So we have 3 moles of hydrogen and 2 moles of ammonia. So 3 to 2, the ratio. Let's get to the third one, which is determining the number of moles. How can we get the number of moles of any substance or of any reactions? So the number of moles between the nitrogen and hydrogen is 1 to 3, the same as the second one. So 1 nitrogen plus 3 hydrogen, 1 to 3. The second one is the ratio between the number of moles between the ammonia and nitrogen is 2 to 3. The third one between the hydrogen and ammonia is 3 to 2. Okay, the same as we said as the number 2.